Look at the state of software engineering today. AI tools have moved past the experimental phase and are actively embedded into the modern development stack. According to the 2025 Stack Overflow Developer Survey, 84% of respondents are already using or planning to use AI tools in their development process. Among professional developers, the frequency is staggering, with 51% deploying these tools daily. But look closer at the data, and a stark contradiction emerges. Despite climbing usage, overall positive sentiment has fallen from over 70%, dropping to 60% today. Experienced developers with the most time in the trenches are tapping the brakes, showing the highest rates of caution. Right now, 46% of developers actively distrust the accuracy of AI outputs, compared to just 33% who trust what these models produce. The extremes are even more revealing. Only 3% of developers report highly trusting AI output, while the highest highly distrust rate belongs to developers with over a decade of experience. High industry adoption rates are masking a growing crisis. Developers are increasingly integrating tools they do not believe in. The source of this friction comes down to a specific issue. 66% of developers cite their biggest frustration as dealing with AI solutions that are almost right but not quite. This leads directly to a massive operational bottleneck. 45% of developers report debugging AI-generated code is more time-consuming than writing it from scratch. The debugging phase now dominates the cycle. Large language models operate without systemic, repository-wide context. They generate syntactically convincing code that fails silently when it interacts with existing infrastructure. Resolving this friction requires looking beyond autonomous agents and considering an architectural shift toward explicitly engineered human-in-the-loop workflows. Fixing the trust paradox is not about waiting for a slightly better LLM. It involves redesigning the technical relationship between the developer and the agent. To understand how to structure that relationship, we need to look at where developers are actively refusing to use AI. For high-responsibility tasks, the refusal rate is overwhelming. 76% of developers have no plans to use AI for deployment and monitoring. Similarly, 69% refuse to integrate AI into project planning. Complex systemic tasks carry too much operational risk. You cannot afford to spend extra time proving out an autonomous black box when a failure could bring down a production environment. Nearly a third of professional developers explicitly note that the AI tools they use consistently struggle with these complex tasks. They contrast this by trusting AI almost exclusively for isolated low-risk functions, like generating standalone syntax or searching for answers in documentation. Autonomous AI is actively relegated to isolated tasks because it fails at systemic responsibility. This makes human directional oversight an absolute requirement. This brings us to the industry buzzword, vibe coding, the idea that you can generate production software strictly by prompting large language models. The hard data tells a different story. 72% of professional developers explicitly reject vibe coding as part of their professional work. Taking that a step further, 38% of developers have absolutely no plans to adopt fully autonomous AI agents. The industry is investing its time across a specific spectrum of tools. On one end, IDE-based assistants like Cursor and Copilot. In the middle, CLI tools like Claude Code. On the far end, isolated container-native agents like Devin. The engineering community is pushing back against unverified autonomy. The developer's role is shifting away from writing raw syntax and moving towards system architecture and output validation. So if developers require validation, how do we architect a system that inherently knows when to stop its own execution and ask the human for help? We solve this with explicitly engineered state management. By pairing orchestration frameworks like LangGraph with vector stores like Elasticsearch, we can build a deliberate human-in-the-loop pipeline. Let's trace a practical workflow, like a system retrieving legal precedents. Step 1 is vector retrieval. A user submits a query. The system queries the vector store and outputs the closest documents. Instead of blindly passing results to an LLM, the workflow deliberately stops. This forces explicit validation. The human operator must disambiguate the document before computation can occur. By treating human intervention as a required functional state rather than an error state, we prevent the LLM from hallucinating an analysis based on the wrong foundational context. Once the developer confirms the correct contextual data, the pipeline resumes execution. Data flows into create draft, creating a split. Path A is straightforward. With all necessary variables, it takes a direct path to completion. But Path B accounts for ambiguity. Detecting missing variables triggers a secondary edge, explicitly requesting clarification and halting the system. This architecture eliminates silent failures. It forces the system to surface its own knowledge gaps directly to the human operator before making critical assumptions. Explicitly defining state management and conditional logic transforms AI. It ceases to be an unpredictable black box and becomes a rigorous, context-aware engineering collaborator. When we look back at the survey data, we see exactly why developers still insist on asking another person for help in a world saturated with advanced tools. The number one reason, cited by 75% of developers, is that they want human intervention when they don't trust AI's answers. Similarly, 61% require a human backstop when dealing with ethical or security concerns regarding the code. This structure functions as a reactive safeguard, engaging the human operator only when the system detects high-risk ambiguity. Historically, the primary bottleneck in software engineering was the sheer mechanical speed of writing raw code. That bottleneck has effectively been removed. The new differentiators for an engineer are deeply understanding business context, architecting robust systems, and ensuring strict reliability. The software engineer now operates as a system director, responsible for validating complex outputs rather than manually producing every line of syntax. The AI trust paradox is an architectural problem at its core. It will not be solved simply by waiting for a slightly larger language model. Unverified autonomy is a massive liability in production environments. It creates endless debugging loops and silent integration failures. For engineering leadership over the next 5 years, the mandate is clear. Your competitive advantage does not come from running the most autonomous agents. It comes from building the most efficient, rigorous human validation loops into your infrastructure. The future of software engineering belongs to the teams that stop blindly hoping for correct outputs and start explicitly engineering trust through deliberate, structured human breakpoints.